Welcome everybody to the Dallas Personal Robotics Group monthly meeting for March 28th, 2026. Today we have a guest speaker to present the Maker's Pet robot, a small inexpensive differential drive robot with a Lidar and a turnkey ROS2 software that lets it map its environment using SLAM and navigate within that map. We also, Mark has an update on the next coming meeting, and then we will get going.
Yeah. So next month's meeting is not going to be here in the North Lobby. It's going to be back in the interactive classroom because this one's booked for a steamroller printing event that day. So I think while we're back in the interactive room, we'll have access to because that's the month before the Rubberama, we'll have access to maybe set up the arena or something for any test runs or the lights.
Yeah, that sounds like a good deal.
Yeah. So yeah, just wanted to let everyone know that we're back there, not in the front room. And obviously, if you're not a member of DMS, then just ring the doorbell and we'll come and get you. Other than that, yeah, we have the Eastfield College line following float parade next week.
Following parade next week.
Yep. It should be some fun. So currently Doug and I are going to that, and everyone else is welcome to come along. So what else? Any other updates that we think of?
What's that involved? What's the floating involved?
Oh, so it's like a little parade event that's being held at Eastfield College. They've been inviting robots to come join. So they invited us. So Doug and I are building, well, he's already built a line follower that will pull a float, and the float's going to have a small DPRG setup. Yeah, so we're going to take that. I'm going to give a little presentation on how we built it and all the lights. But it should be nice. It's a good little event, a social event.
It's more of a social event, I think.
Yeah.
Yes. Serious. It's not a well. Technically, it's a competition because they're going to give out a couple of prizes, but like best presentation or something. But our intent is just to be there.
Yeah, we're good. Yeah, I think that's it.
Okay, thank you. So now we have Ilia Ovsiannikov. I don't know if I'm pronouncing that right.
Don't worry.
I apologize. Ilia developed the Maker's Pet robot kit and the software, and he's going to present some information about it and hopefully get us all up to speed. A couple of our members have built the robot and are having very good luck with it. So go ahead, Ilia. Thank you.
Thank you, Pat, and thank everyone for having me. So I'm Ilia Ovsiannikov. Let me start the presentation. Just 1 second. Let me share my screen. Presentation is starting. Window. Okay. Share. Slideshow. All right. So by the way, please, if I talk too much, please stop me anytime and please ask me questions. Yeah, if you want me to talk about something in particular, please let me know, because I'm new to this. I'm new to DPRG. I'd love to know more about your interests so that I can talk about that. Anyway, so I'm Ilia, and I'm a retired engineer. My specialty is camera sensors for cell phones, for mobile phones. As a background to understand where I'm coming from, I designed the very first imaging sensors that went into the iPhone and into the Nokias and Motorola Razrs. It was the beginning of 2000s, and after that I worked on other types of imaging sensors like distance sensors, the depth cameras. So I designed the silicon. This is my specialty, and the processing, image processing for those. And later in my career, I worked at Samsung for a long time, and before that I worked at Micron Technology. I suppose you know that company very well. And at Samsung, I also designed artificial intelligence inference agents for mobile silicon. So that's this is what I've done as an engineer. So after and I retired about when the COVID started, and I switched to. So it's very difficult to retire. So it's boring to do nothing. So I basically I switched to something else instead of working for hire, and that includes robotics. And also when it comes to robotics, I have a family, and just 1 second. I went through, when my older daughter was in middle school, I volunteered as a robotics coach for VEX Robotics. So they were doing VEX Robotics and the competitions. I'm not sure if you know this, but this is what we did. And we went to like nationals and the world championship, and I had a all girls VEX robotics team. So they're happy because they did pretty well in the worlds. So that's my background. And then back to Makerspec. So Makerspec is basically, it's a byproduct of what I'm building otherwise. So I just made it public. I don't make really money off this. It's a very small operation, very, very small. It's just me. I design all the boards and all the 3D and everything. And I figured out how to manufacture them in China, the boards at GLCCB. And then and my wife takes does the shipping, once in a while. So, all right. So anyway, so this is the kid. I suppose you're familiar, but anyway, I'll just cover it from the top. So it's a ROS 2 robot, a very small robot. I made it very small so that it's inexpensive to ship. And it has a differential drive. It has a lidar, and it does all the things that ROS 2 is supposed to do, like mapping and navigation and SLAM, and also frontier exploration. And I made instructions, a series of videos for anyone to, and the knowledge of robotics is not required. So it's 0 to hero, so to speak. I made it. So it was inspired by TurtleBot. So I have a TurtleBot somewhere, and I used it. It is expensive, TurtleBot. So I designed this the Makerspec robot to be cost effective, very, very low cost. So okay, this is how it looks without the 3D, without the base. Basically, there are 2 motors. There is like 6 AA batteries or 2 lithium cells, and there is a lidar connected. So instead of using a Raspberry Pi, which is right now pretty expensive to buy, I built this using an MCU, and I moved all the processing to the PC, and this is to reduce the cost. So the lidar. The lidar is it's a 2D lidar. The maximum range is about 8 meters, and it spins about by default. It does like 6 rotations per second to capture the distance all around the robot. Now, over time I've noticed that thanks to the proliferation of inexpensive Chinese vacuum cleaners with lidar, the prices for lidars like this they dropped a lot. So it is possible to get a lidar on AliExpress for very very little money. So I was thinking about capitalizing on that, and this is how I ended up using these lidars. Anyway, so I designed there are 2 boards. One is the carrier board, and the other is the ESP32 board. I designed the motor board, and then I used off-the-shelf ESP32 boards for this, and then I decided to design my own ESP32 board as well. And the motor drivers, they have 2 channels, and they power like those little N20 motors, like this, like those on the picture. Those motors have encoders, and I made them fairly stable so that the ROS2 navigation and mapping can use the odometry from the robot. Okay, so the base is pretty small. It is about 120 centimeters. No, not one. Yeah, that's a mistake. Okay, it's a like 12 centimeters in diameter, not 120. Okay, the wheel. Yeah, okay, that's embarrassing. The wheels are 43 centimeters. Okay, I have a.
From centimeters to millimeters.
Oh yes. That's. Anyway, so the wheels are pretty small as well, and everything is 3D printed. The power is 6 AA batteries. Because the robot is running on a microcontroller, it doesn't have to haul a big battery. So there is no serious compute happening on the robot. Okay, so the ROS2 support is, it was first Humboldt and Iron and now Jazzy. It took me quite a while to migrate from Iron to Jazzy because especially the migrating the simulations, the gazebo simulations, it took a while. There is there are breaking changes in ROS2 moving from one release to the other. But now it works, it's all fine. Okay, so the firmware, I built the firmware based on Arduino, so it requires Arduino IDE to build it. And the reason is, because I wanted to make this kit available to as many people as possible, and Arduino is one of the biggest communities out there I can tap into. It's very easy to use, and something that I wanted to do. Okay, and just about basically everything is open source, from like hardware, firmware, schematics, and CAD, everything. Okay, so let's see, next one. Okay, so this is the ESP32 board that I designed. So it's not necessary to use specifically this board, because there are lots of boards that can be used instead of this one. But for some reasons, I designed it anyway. So what the difference between those boards, the other compatible boards that are available off the shelf, is it uses a newer chip, a newer module of ESP32 with a better Wi-Fi performance, and it also uses DC to DC power converter, that it's not an LDO that just, you know, burns the energy, converts it to heat, but instead it has a coil, and it's a lot more efficient, converting from 5-volt external power to 3.3 volts into onboard power that the ESP32 chip requires. So yeah, that's that. So it has Wi-Fi. It's a 2 gigahertz Wi-Fi. There is no 5 gigahertz Wi-Fi. One of the reasons is that 5 gigahertz Wi-Fi doesn't really work. So I mean, it can work fine with robots, but because robots inside the house, they can go at, you know, anywhere. Sometimes there are 5 gigahertz Wi-Fi has like dead spots with poor reception. So 2 gigahertz Wi-Fi is much better with that respect. Okay, so the microcontroller, I think you're familiar with it, but I'll just cover it anyway. So it's a wonderful microcontroller. It has almost half a megabyte of SRAM on board, and it runs at 200 up to 240 megahertz, and it's 32-bit, and I like it a lot for the price. It is very, very low cost. So and it comes with a huge community. It is relatively easy to resolve any problems. There's a huge community, so it's so popular out there. So this is why I decided to go with this microcontroller instead of, say, ARM. Anyway, and it has a micro USB for programming and for debugging, and it uses Arduino IDE. Well, I mean, it's not required, the Arduino IDE. You can also use the Espressif toolchain. Espressif is the company that makes it, so you can use their toolchain, their own toolchain. All right, so it also has Bluetooth, but I'm not using Bluetooth in this particular firmware. Okay, so motor drivers. Now, again, the design was the robot itself. The kit was inspired by TurtleBot 3, and TurtleBot 3 uses its own board, and it's fairly expensive. It's like almost $200. It costs almost $200, and it's drivers, motor drivers and it has an MCU on the board. So I thought it was expensive, this board. So I designed a small carrier board. It doesn't have an MCU microcontroller, and it has 2 channels for, like, it uses Texas Instruments motor drivers with like current limit and over temperature, you know, safety features. And it's basically designed for those little motors, like 12 volts, and also I made it's selectable, actually, 12 volts or 24 volts. There are lots of, so when I looked at the motors, I saw I can see lots of motors available that run at 3 volts or 6 volts or 9 volts. When I tried those motors, they just felt underpowered. So this is why but when I used the 12 power motor, I'm sorry, 12 volt motor, same size of motor, it was performing wonderfully. This is why I went with 12 volts and 24 volts. This is selectable on the board. So, and this is very important for ROS2 performance. Basically, I concluded that I cannot use motors that are too weak, underpowered. The motors have to have plenty of power. Otherwise, Otherwise, the mapping can there can be problems with mapping and navigation. So I cannot use those cheap motors that are used for Arduino non-ROS2 without like once you start moving. I'm sorry. Once you start using mapping and navigation in ROS2, you really need your powers to your motors to have plenty of power, especially for low speeds. So the mapping mapping works best when the robot moves slowly, and even though the robot moves slowly, the motors have to function very well. They have to have plenty of torque, so that the movement is nice and smooth and not jittery, and the robot doesn't get stuck, for example, when it rotates and things like this. And if there are any obstacles, the robot would go over those obstacles at a slow speed and still do well. Anyway, so what happens on this board is that, okay, there are two motor drivers. There is a DC to DC converter that converts a battery power to the motor power, and another DC to DC converter that converts battery power to ESP32 5 volts, giving it 5 volts. And also all lidars, practically all lidars, 2D lidars, they also use 5 volts, so that 5 volt power goes to the lidar as well. And encoders, motor encoders, also use 5 volts. There is also a battery voltage sensor, just a resistor divider, but it's available and it's used by the firmware. So all of this is open source again, and there is an 8-pin header right here. I'm not sure if I can I? Okay, oops. So yeah, anyway, there is an 8-pin header that supports. I made it in such a way so that it supports a very large variety of 2D lidars. Like I got like 25 plus lidar models supported right now in hardware and software. In firmware, I'm sorry. Okay, so
actually, I have a question about the connector that for the lidar that comes with it. It looked like the pin connections were supposed to be, I guess, more on the far side or the back side, not the set that's supposed to in. Is that right?
Yeah.
Okay.
The outer row. Yeah.
Yeah. Okay. Oh, yeah, the outer row. Okay. And you said the voltage is selectable. Is that also selectable at that header there?
Oh, the voltage, no, for the LiDAR, it's 5 volt. I haven't seen a LiDAR that runs on 3.3 volts yet.
Oh,
yeah, it's fixed.
okay. I thought you said the motor voltage was selectable.
The motor voltage is selectable. Yes, there is what is it called? You can cut a trace. There is a special marked place where you can cut a trace, and that will switch the voltage to 24 volts. And so okay. Anyway, okay, the architecture. So so basically, just about everything, including ROS2, runs on PC, on a local PC. The robot itself runs Arduino. It has this microcontroller, ESP32 microcontroller, and the firmware runs Micro-ROS to communicate with ROS2 on the PC, on the local PC. So Micro-ROS is standard. It's part of ROS, and it was made specifically for cases like this. And it's supposed to. Its goal is to make it easy to connect small little microcontrollers to ROS. So I'm using it a little bit differently to compare to what it was, how it was supposed to work, in the sense that I'm streaming raw Lidar data over Micro-ROS to the local PC, and then this happens over Wi-Fi and using UDP, so the packets can get dropped. So originally, Micro-ROS is supposed to just exchange a few commands, like going to the microcontroller and sensor readings going back to the PC, to the ROS2 PC. But I'm sort of stressing out Micro-ROS by sending a lot more data than it's supposed to handle. But it's handling this data, you know, fine, and I'm very thankful to the developers of Micro-ROS. So it's doing great. Okay, the communication happens over UDP because it is important to get the data quick instead of reliably. So it is possible to send the data over TCP/IP, but for robotics, the better choice seems to be UDP communication. Otherwise, the data can get delayed when Wi-Fi is busy or you know, has poor reception, poor signal. So the PC, the ROS2 PC, I sort of followed ROS2 standards and development standards, and they recommend using Docker containers to develop all the ROS2 software. Using those Docker containers makes it easy to make the software. It's like it fixes the versioning problem that, you know, we can have different versions of Linux or ROS2 and things like this. The container just fixes the version of all the components and libraries, and you get the whole container, and it runs as just exactly the way the developer built it. So this is why I'm using containers, but it's not required. It's possible to run ROS2 without containers. It's also fine. So let's see. Oh, okay. Okay, there is. I'm not sure if you have used it, but there is also out-of-the-box simulation that works. That comes with the firmware, with the software, and it works both in Iron and Jazzy. And as I mentioned, simulation was basically broken moving from Iron to Jazzy. There were breaking changes in the ROS2 releases, the way Gazebo worked, the way Gazebo 3D simulator worked. So it took me quite a while to port the simulation to make it work on Jazzy, but now it works and it looks all fine. Simulation is helpful, at least to me, to debug and test mappings, navigation, SLAM, and frontier exploration without having to rerun the physical robot every time. And this is one of the scenes that I also composed. Like, I built this scene in like a few assets in the scene to you know, for testing purposes. Though the majority of assets is something, you know, somebody else, like they were made by someone else. And all of this is open source. Okay, so okay, and there is, I almost forgot to mention, there is the most important thing in the simulations is the red ball. That red ball, I wanted to make the the robot to play with that ball, and it can play, but so the simulation works. It works, but I still have to make a game for it, develop a game for it. Anyway, next is okay. The mapping and navigation. It works. It's supposed to be working out of the box, and there are several choices. There is Google Cartographer. This is basically the best mapping software out there, available as open source. And there is nav2 Slam, which is also pretty good. nav2 is available with ROS2, not ROS. The second version of ROS only. And there is also Frontier Exploration. It's a node that will drive the robot to explore everything on the map. It will check for any places on the map that have not been explored, and it will have the robot navigate over there and map those places. The Frontier Exploration is not something that I developed. It was developed by someone else, and the code is on GitHub. All right, so video instructions. I've made 8 videos, and I tried to make them as complete as possible, the whole series, so that I don't have to reduce the load on myself, supporting building those kits. So over the year, I've got about 2,000 YouTube subscriptions, and there is an active support forum on GitHub that you're welcome, most welcome to use. It's pretty active. There've been about 100 threads. If there are any problems, please just open the thread or browse the existing threads to find some answers. All right, so this page is just a bunch of links for your reference, so that you can, if you need, you can look them up later, including the open source, the schematics, the 3D, and everything else. Okay, just a quick slide comparing the two robot kits. One is the MakerSpet, and the other is Turtlebot 3. So both run ROS2, both have lidars with similar characteristics. Turtlebot 3 does have IMU, and MakerSpet doesn't. One of the reasons, so there are 2 reasons why MakerSpet does not have IMU. One reason is that streaming IMU over Wi-Fi can IMU has to it's a lot of data, and it has to be delivered quickly. So sending it over Wi-Fi might be problematic. So it's possible, but I would expect that it can cause some issues. This is opposed to having IMU on board sitting next to the microcontroller when there is no problem with the communication. And second is that IMU is not really necessary for mapping. Google Cartographer and other systems, similar systems, they do just fine without IMU. And to further improve the reliability of mapping, I made sure that I designed the wheels, the robot's wheels, with this like rubber ring, so that they have good traction, and the odometry is fairly reliable. So the mapping algorithm can rely on the odometry, and this works so far nicely. GPU, fingers crossed. Okay, and the compute, the last, oh, okay, there is an optional color camera on the total board. And so I did not add color camera because it would be sending a lot of data. And ESP32 microcontroller would not be able to deal with this at any good, frame rate. It can send. It's powerful enough to send video or images over Wi-Fi, but the frame rate will not be as high as as we might want to. Okay, and the compute is ESP32MC, as opposed to having a Raspberry Pi. So, and I also I studied. I did the research, and I'm a big fan of Linear Robot, and I as far as I know, DPRG is maintaining Linear Robot, and I looked at it a lot, as it's a great point of reference for me. It's basically in a similar class. All right. So next up, this is a part of my collections of lidars. I collected so many lidars, different models, and I wrote a firmware library. It's an open source firmware library that supports those lidars. It does the decoding, and it runs in Arduino, and with some, and it can also makes it possible to run those lidars with ROS2, which is basically what this kit does. And almost all of these lidars in the picture, the Maker-Spec kit supports those lidars. All you have to do is edit a file, configuration file in Arduino IDE, and upload it to the robot, to the ESP32 firmware microcontroller, and it will switch to using the model that you want, the lidar model that you want. And you also there's one more change on your ROS2 PC. You will have to include an argument when you launch the bring up file for the Maker-Spec robot. You will have to specify which lidar model you're using. Then it will work. Okay, so now the firmware that I wrote, it also works with a number of alternative bases, and I 3D printed those, and this is one of the bases. Like it's the one on the left. It's a mock vacuum, for example. So all of them are differential drive. So this one has bigger wheels, and it uses. Let me see if you can see it on the camera. Okay, it has bigger wheels. I hope you can see them. It still runs on ESP32. There is a lidar here, but the difference is that the driver board is a little different. So it's another driver board that I designed. It drives. It's made for brushless DC motors, and the motors are bigger and more powerful. And sure if you can see them. Okay, so this is the motor. It's bigger, yeah, and it drives a bigger wheel. And why I did that? One reason is that so my mission is to build. So here's my problem. So let's say I build this kit, right, and learn some ROS. It's nice, but then there is what do I do next? Once I've run mapping and navigation, it's like a full sudden stop. I'd love to make this robot do more things, and to do more things, I need software for my robot. I want to make my robot to do something useful, or maybe something entertaining, to play something, to act as a pet. This is why Maker's Pet is called it has pet in the name. So I need software, and I need also faster, more powerful motors, so that, for example, the robot could kick a ball and maybe play soccer. So this is why I also have a board for brushless motors that are more powerful and faster. So these the tiny motors that the kit is using, they're not good enough for real play. All right, so that brings me to what I'm doing right now. So my focus right now is I'm running a startup over here in California, where we're building a platform so that robots can run apps, very similar to how you run apps on smartphones, but in this case, apps for robots, so that you can have robots do something useful or entertaining. This is my younger daughter, and well, yeah, she is pictured, playing with the robot. So I have a video. Oh, okay. First, it's the architecture to make sense of it. Okay, so this is how it's supposed to work, and this is at prototype stage right now, what I'm doing, and this also will work with the kit, the Maker's Pet kit. So this is basically becomes like a free extension for the kit, basically free software for the kit. Now, so the kit, the local PC of the kit that's used in the kit already uses Linux, and already uses ROS2, and it already has the robot definition, the ROS2 packages that define the robot. And what we're adding is a platform layer. It's like a SDK. And on top of that SDK, you can develop and run third-party apps. So this is different from developing code inside of ROS, because all code inside of ROS, it has to be trusted. So the difference is that apps, you can have, you can download an app that somebody else wrote, and that app is not trusted. You didn't develop it. Just a similar case like smartphones. You're buying or downloading free apps that somebody else made, and you're still feeling safe, to use them. And for robots, it's even more important, because it's a physical device. It moves around. It can hit things and people. So the app that you download, even if the app is not trusted, there must be things in place, like guardrails that keep the app safe, so like from cheating people, for example. So this is part of the software that runs those apps. It keeps the apps safe in many ways. Okay, another element is the App Store. And App Store is similar. It's a website, and it's similar to Apple App Store and Google App Store. This is where you can search for apps and click to download, to install on your computer, on your robot and run those apps, and they have a UI. You can interact with them and things like this. So that's that. And this is a video I'd like to show, if you don't mind. This is a concept video of how I hope it will work. Older daughter playing with mock vacuum. And this is my daughter racing the vacuum. It's fun for her. And this is hide and seek. The robot will hide, find a place to hide. It has a lidar, so it can find a place to hide. And then my daughter will go and look for the robot. And this is reverse hide and seek, where my daughter hides and the robot will go look for my daughter. And the robot has a lidar, and this is not perfect. It's not a camera, a full camera, but it's enough for the robot to see the child's legs, feet. And this is sketch, for example. The robot can see the ball. This is having a lidar enough for that. Okay, so that's that.
Okay.
So this is what I'm trying to build. And Maker's Pet is essentially it's a byproduct, like a byproduct of the main effort, which is to build apps. I use Maker's Pet, like the kit and the software and the firmware and the hardware a lot to to develop the apps platform and to test the apps platform. Okay, so next is, so I'm almost finished. Next is that I'm hoping to interface the apps platform to LeRobot. I'm not sure if you know it. I suppose you've heard about LeRobot. It's a very, very popular. It's a very, very popular robotic system, DIY robotic system, with a huge community, and they are doing machine learning for manipulation. So they use a robotic arm like this to do manipulation, and they train models, AI models, to manipulate things automatically, to learn how to pick up like cubes or, I don't know, a spoon or something like this. And this is something that I wanted to do, to make the base and the apps run with that arm that they have. So I do already have SDK available, and it's open source, and I have a ROS2 SDK that comes with it, that makes basically this connects ROS2 robots to the App Store and makes it possible to run apps. And there is a developers homepage with the mailing list that I set up, and this is coming to. I'm working on this very actively last about half year. So, and I hope this will be useful to lots of robotics enthusiasts. Okay, I'm almost finished. So as far as the online store that I'm running, little online store, we've shipped to 31 countries over the last year. So it's getting a little bit popular, I hope. And that's all. That's all I have. Thank you for having me. And if you have any questions, please do ask me any questions.
Well, thank you very much, Ilia. That was very informative.
You're welcome, Pat.
Anyone have any questions for Ilia?
I have a question.
Yeah.
So out of your LiDAR collection, is there one that performs the best, or are they all pretty much similar in performance?
I would say there are two generations of LiDARs, 2D LiDARs broadly. The first generation is, let me see if I can demonstrate it. Just 1 second. 1 second. I'll grab one.
Which is meaning like the original LiDARs that had an external processor to get them to run at speed of 300 RPMs and parse the data. Yeah.
How many members have the whole platform up and running fully?
The XV11. XV11.
So this is a third generation LiDAR. It is heavy. I can feel like it's heavy, and it is bigger than the LiDAR that the kit comes from. The kit comes with. So this one is about, I would say, is the LG14P, the kit's LiDAR. It is a lot lighter and visibly, I'm not sure if you can see this, it's smaller. And one more important distinction is that okay, I'm getting ahead of myself. So this is first generation LiDAR used maybe 10 years ago in the first LiDAR equipped vacuum cleaners. This is all Chinese, by the way. I don't think US or Europe makes any of this anymore. And this is second generation LiDAR. It's light and it consumes a lot less power, and it is also a lot more immune to bright light in the room. So LiDARs, they have, if the light is too bright, especially if there is outdoor light or incandescent light with a lot of IR in it, that kind of illumination can impair the LiDAR. It's impair the performance. So first generation LiDARs, they are not as immune to that illumination, and second generation LiDARs are much better. So when you look at those LiDARs, when you're selecting one, yeah, I would recommend, of course, using at least second generation. Now there is also, by the way, but the first generation LiDARs are dirt cheap. They're just incredibly cheap. Maybe they're not even manufactured anymore. I'm not sure though. But there are lots of LiDARs like this, and they're taken from used vacuum cleaners, and then they're resold on AliExpress usually, and then they still work very well. I don't have any complaints except for weight and maybe a little more power consumption, but they still work fine for the users that I have for them. Then there is, I would say, there is yet another category of LiDARs. I don't have. Do I have this LiDAR? No, I don't have this LiDAR actually. But there are time-of-flight LiDARs. I believe that their performance is similar to the second generation LiDAR that I showed. But the principle of their operation is different. So these two, they use triangulation. They have basically two holes. This hole is the laser, and the laser basically is very similar to laser pointer. I'm sorry, the laser used in laser pointers. except that it's invisible. It's near infrared. It's spectrum. But otherwise, it's very similar. And the second hole here is it's a camera. It's simply a camera, and actually you can see the optics of this camera in this exposed in this. This is the Delta 2 G3i robotics lidar. The camera. So they use triangulation. The laser is shining that way, is pointing that way, and the camera is looking this way. And you take a picture of the laser, and you can see where the spot is in the picture. And by looking at the picture, you can tell how far is your laser spot. Time of flight. Now, time of flight lidars, they use a different sensing. They still have a laser or laser diode, but they have only one hole. Well, actually, maybe I shouldn't say that. They still have 2 holes, but the principle is different. They measure the time of flight of the laser impulse. But performance, I don't think they are. I think they're very roughly, very generally saying they're similar to this second generation of lidars. So yeah, that's that, and the pricing is about same. So, but I'm fine with first generation lidars as long as the weight and power consumption fits the budget. So I hope I answered your question. If I didn't, please ask me.
Is there a particular brand that you recommend?
A particular brand.
Model.
Can you go to the
Yes.
Can you go to the slide that you have of all the lidars?
Yes.
You went that. Which one?
So personally, I like LG Robot, the one at the top on the left. But it doesn't mean other lidars are, inferior. It's just that I happen to spend a lot of time with this model, and it seems I can rely on it. Basically, it's reliable. Other I did also evaluate YD lidar, and I was actually considering. Let me see, just one second.
Yeah, I wonder if that XV11 required an external processor.
No, it came. No, that's just a serial port. You have them. Otherwise, you got to interpret the signal.
Yeah.
It comes coded basically.
So I did explore YD lidar X3. Which one actually? Let me see. I did explore YD lidar. I spent considerable time testing it, and here is the kit, the version of the kit that has YD lidar mounted on it. So it's a working version. Now, but I went with LG Robot LT14P because the pricing was basically identical when I was so I had to choose which one to use with the kit. The pricing was identical, and YD lidar consumed more power, and it was actually wobbling. So the problem was that when it was spinning, it's a little out of balance, so that the kit, because the kit is so light and small, the kit was wobbling visibly. So this is why I went with LD Robot, which looks perfectly balanced. There is no wobbling, and this is so. Basically, to answer your question, I recommend LD Robot because it seems fine. You know, I've tested it a lot. Yeah, but other models, you have to look out for things like that, like wobbling, more power, and things like this.
I was kind of curious. There used to be a guy in the club, James LaCroix, that basically grabbed a bunch of broken Nito robots, and he was pulling out the LiDAR, but he made a separate interface board for the LiDAR to, get the motor to spin at 300 RPMs and like a control loop, and to basically parse the data that came out of it. I don't know if that's the Nito XV11. Are you familiar with that one?
Nito XV11. Yes. I have, obviously I have one of that, and I brought it up, and yes, I actually did exactly the same. I had to build a PID loop,
right,
to stabilize its frequency, and I found some open source code to decode data. Yes, I had to basically do the same. Yeah, there is so then I published a library, open source library that does that, all of that.
Yeah.
But yes. So Nito, just for your information, I'm sorry.
Go ahead.
So Nito, I think it was a German company, and it went out of business, and it stopped making those LiDARs a long time ago. I think almost 10 years ago. And actually, so many Chinese robots, I'm sorry, Chinese LiDARs like this, they have they copied the Nito protocol, and I think they copied basically the design maybe as well. So a lot of these LiDARs that you can see, they're actually using Nito protocol. Yeah.
Anyway, yeah, so a bunch of guys in the club had those Nito LiDARs. He sold the little board, and he'd sell you the whole unit that he would take out of broken Nitos. So that was another question I had. I think the Nito is only good for 360 or 360 points. Are the other ones, like the LD Robot LiDAR, does that have more points that it takes?
Good question. I can answer actually in I can answer this question. Just 1 second. So I have one more GitHub repository where I keep a table, a specs table for these LiDARs, and 1 second. Let's take a look. Let's see, Nito. Is there Nito? Okay, so Nito. Okay, so Nito captures about 2,000 points per rotation. So very good. Yeah, this is a great question. And the very first Chinese LiDARs, like this, they also have the same performance, like about 2,000 points per rotation. But let me see. For example, YD LiDAR here, it's 5,000 points, 3,000 points, 4,000 points. So yes, the number of points went up about roughly doubled, I would say, roughly doubled compared to Nito. And if you're willing to spend more, of course, they have a much better numbers, like 8,000 points, 16, and so on. And I'm just curious, LG. Okay, so the MakerSpec kit is capturing 4,000 points, so about twice.
Okay. Yeah, I can't remember ours. We only looked at 360 points, like 1 per degree.
Yeah, the software will look at it 1 per degree, but I do know that other models look
Had many more points.
and they have to run it a lot higher. See, the Nito ran at what was it, 1.5, 200, and like the RP Lidar A1, I think, runs it like 2 hours.
Look, that's,
Yeah, I
so
mean,
much
that's why
faster.
the serial port is really humming.
Yeah.
Yes, there you go. A1, 8,000 actually. Yeah, 8,000.
Well, you have to be careful with A1s because there's multiple versions. You can see I think that one's Mark 6 or Mark 8. I can't quite read it. Yeah, and, so if you buy one on eBay or something like that, and you get a Mark 2, you're not going to be happy. Okay. Why that? Because they don't. Most of people's packages have moved on from there, and Lidar and RP Lidar itself, or SlamTech or whatever they call themselves, don't support it. You can download from their GitHub. It won't do the early A1s. It will only do the later A1s. So unless you found somebody who happens to have that library from way back when. Because that was their first model. That's why it's called A1. Right. Yeah. But they're trying to compete with these other Chinese models. So they had to keep them up in the game.
I've got a question. So what are the top 3 enhancements you're getting as requests from your user community for the kit as a whole?
Good question. Well, actually, I only got enhancement requests from you guys. Yes, there was a request for battery charger, built-in battery charger, and to plug in to remove some holes, unused holes in the base. But actually, maybe oddly enough, I'm not getting improvements requests now that I'm thinking about it. Yeah, it's. I'm getting lots of questions like how to bring it up or this and that, but not about improvements.
Yeah. Yeah, I was kind of curious about that. How easy is it to add, like, a servo, say for a claw that grabs a can or something, something like that? Is that difficult to do? Does it have to be done in ROS? Are there any spare pins on the processor that you could use, or how would you do that?
I'm sorry, I had trouble hearing. It's a servo, like adding a servo to the kit, right?
Right. Yeah. My expansion.
Well, I think so. The main limit. So I think it's possible, but the main limitation to look out for is it's just that the ESP32 microcontroller, it doesn't have too many outputs, GPIOs. So I think there are enough outputs for a servo, and that will be fine for a single servo. So yeah, but yeah, that would be possible. So it should be. I would just set up one more PW channel and configure it to use a GPIO that you want, and plug in a servo, and then modify the firmware so that there would be one more. So the firmware, the Micro-ROS component will listen to the topic, the servo command topic, and that would be it.
Yeah. But just add a servo.
Yeah.
But you don't get away with that, guys. You got to have a sensor, make the servo go.
Oh, yeah.
Before you know it, you're going to take 3 or 4 pins.
Probably, yeah.
Should be good. Yeah, that was one little design feature I liked, is having a double row of sockets on the board so you can plug in next to the pins.
Yeah,
That's a nice little feature.
Yep. It's not very been used, right?
Yeah.
Yeah, look at the size of that Lidar compared to the data library.
Yeah.
At least 2 times that size.
Yeah, yeah.
Really?
Yeah.
Do you have a pinout schematic that shows extra pins? Available
Yes,
pins?
yes. Yes, I do. All the schematics.
Yeah.
Let me see.
I think you showed a page of links.
Yes. Let's see. It will be. All right, so come on.
Yeah.
There you go. So yeah, it's in the MakerSpet, like under MakerSpet on GitHub store. There you go. So yeah, there should be a few.
The code that goes into the ESP32, it looked like there were maybe a couple different versions out there. I was kind of curious which is the latest one or the one we should use. I know there was a firmware -0.8.6, I think, and then just plain firmware, no version or number behind it. So could you tell me which one is the latest one, or the one we should use now?
Okay, sure. Let me see what's going on there. As far as and I'll circle back to the ESP to answer your question to microcontrollers. I would recommend to use the latest release. When I make a release, it's tested, but let me see. Just yes, I would just recommend using the latest release, and there is a change log. Sometimes I would like this. I would add another Lidar support, and then there was a transition to Jazzy. Let me see, bug fix. So yes, just the latest, if you will. Please use the latest version. It's always a good idea. And as far as ESP32, let me let me answer this question. Just 1 second. Expressive hardware. So, okay. Oops. This is the manufacturer website for the ESP32.
Yeah.
And they have a few of those. So ESP32 itself, it's deprecated. They don't actually make those anymore. It won't even navigate there for some reason. So the closest and what I use ESP32E, which is pretty much identical, but they fixed something in the Wi-Fi. The Wi-Fi performance, it's cleaner. It's a different story. I had to go to do FCC, like I tried doing FCC certification for ESP32, and it's a different story. I can tell it some other time. So ESP32E is much cleaner in this sense, and otherwise it's identical in the pinout, performance, software, everything. So, but there are two other things available. ESP32C, it's okay. Just to make it simple, the kit also runs on the S version, especially S3. If you want something that is more powerful than like an upgrade, then S3 is a great upgrade. It's a very good upgrade. It has more GPIO, it has more compute, things like this, and the kit already supports it. So this is the firmware for the kit, and there are configuration files available that I put here. So here is the S3 configuration file. So if you use this configuration file with ESP32 S3, so it's supposed to work. There is S3. I'm not sure what this is. Oh, maybe
You guys will repeat. Yeah.
Maybe I can make it larger. Okay, there you go. ESP32 S3. I also made the kit work with Nano, and they do use S3 as well. So Arduino Nano is the Arduino made by Arduino company. They have a Nano board, and that board is based on ESP32 S3, and it also works. I was able to bring it up. So the other models, the kit won't work with those. So I don't remember off the top of my head exactly the details, but I think the C series, they're not as powerful. So or they have limited GPIO. For some reason, I didn't use them. So S3 is something that you should use if you want an upgrade.
Okay.
Can you work on Arduino 4 and CANCOM, Arduino number, Queen Q? Can you work on that?
I'm sorry, it was difficult to hear. Can it work on what?
Can that Lidar work on Arduino 4, and can it work on Arduino Yukon Queen, whatever Q?
Yeah, there's a board.
It's a board.
Yeah.
It's for Arduino.
It's like the latest R4.
Yeah.
Like what?
Oh, it's the alternative boards. Well, the firmware Well, yeah, I would have to check. It's hard to say. I would have to check.
I know Arduino got a board called Arduino, Q, for print pong.
Oh, Q, Arduino Q. Let me see.
Does it work on that? And Arduino 4?
Oh, I see. Uh, wow, it has 4 gigabytes. Well, it's almost like Raspberry Pi. You know, this is a different class. Different class.
This guy also takes 15 watts, so
Yeah.
Yeah, but very impressive for $59. It's yeah, I think it's possible to port it, but I think you can run maybe even the whole ROS2 on this board. It's like Raspberry 2.
Python?
Sorry.
Huh? Can I use the ROS? Can I use Python?
Does it use any Python?
Yeah.
So the local PC does run a lot of Python. Yes. But not the microcontroller. The ESP32 does not run Python. No, not the kit at least. So the ESP32 can run Python. There is Python for ESP32. I think it's called MicroPython, but the kit is not using it. Python would be too slow to run this real time.
Ilia, do you have any plans to upgrade to a Kilted? Yeah.
Oh, Kilted. I haven't started, but maybe when it's time to port, it will be relatively easy. I hope to port because there should be no breaking changes. Just a few edits in the build file, the Docker build file.
Very cool.
Are you sticking with the long-term release versions of ROS for it?
Yes, of course. Of course. Otherwise, I would have to. Yeah. Otherwise, it's trouble. It's if I don't stick with those.
Well, he did do Iron, so that was an interim release.
It was when I didn't even well. I think I moved to Iron because it had upgrades for NAV2, some considerable upgrades, so I had to move to it. Yes.
Okay. Any other questions?
I do. I'm just trying to
Yeah.
Now, the most important question, do you have an actual corgi for your logo?
Oh, corgi, yeah. Well, this is I used to have a dog, so not corgi, but very similar. But the poor guy, he was old, and I lost my dog, and so now he's the logo. I miss him a lot. I miss him very much. The whole family misses him.
Yeah. He will live on. Yeah. Yeah. I do love the logo with the little Wi-Fi symbol as a boat.
Well, I think one of the things Mike was trying to get at was having, let me get his picture.
Yeah.
There you go.
There you go.
If, for a lot of us, the idea of using a laptop is not where we want to go. We want everything to be contained on the specific computer, robot, so that the robot itself is self-contained. And so, obviously that's not a cheap solution. and compared to the MakerPad, which is by offloading everything to the PC, it saves a lot of money. So, you know, ideally, like I say, we'd like to see it all on one robot. So the question would be, from your experience with the ROS2, which I'm sure you gained quite a bit in the last year, can the Arduino, was it Venturo?
Ventura, yeah,
Venturo Q.
Ventuno.
It's kind of like the newest chip on the block. It's kind of like a combination of an ARM chip and a ARM chip with AI and a Raspberry Pi. It's not a Raspberry Pi, it's a Snapdragon. So the question is, do you think this would be viable or does ROS itself just take so much that you need something like a laptop or an Intel processor?
Well, let me check. So it did catch my attention, and I'm aware that Qualcomm acquired Arduino, so Arduino is now part of Qualcomm, and it's great to see a board like this coming out. This is great. Let me maybe try to answer. So this is Arduino Q versus Raspberry Pi 5.
Yeah, no, not well.
The new one's
the new one is
Ventuno.
called Ventuno. So so between Arduino and the Q, it's VENT.
VEN.
Oh, and then UINO.
UINO.
It's like Arduino, but Ventuno.
Okay.
Something like this?
Yeah.
Oh.
And then the Q on the end of it, I believe.
There you go.
Yeah,
That's
yeah,
it.
there it is.
That's trying to compete more with NVIDIA.
Yeah.
Style.
Oh, I see.
Yeah.
Oh.
So the Q is kind of like competing with the Raspberry Pi. And the other one has got kind of competing with the NVIDIA. Yeah.
Well, let me see. So first time I'm hearing about Ventuno.
Yeah.
I think it's vaporware right now. I mean, but
It hasn't been released yet.
Yeah.
Oh, I see. Well, that looks. If I read this right, and if this is real, that 40 tops. This is fantastic. This
costs more than your kit will.
I'm sure. So I'm familiar with NVIDIA. What is it? Jetson Nano. So I've used that. This looks impressive. 16 gigabyte. Yeah, that could. Yeah. So to answer your question, definitely yes. This can run ROS2, and this can run object recognition. Yes, absolutely. So just to give you a,
there is a problem, and doesn't ROS2 pretty much to run turnkey without any issue have to run on what's the name of it? What Linux version? Ubuntu. Yeah, doesn't it have to run on Ubuntu? If you run it on anything else, you get kind of weird.
It's only supported on Ubuntu.
Yeah,
that's a tricky word, right? Supported. It's officially supported, and they won't even look at you if you're not using that. But it does run on a lot of different distros.
Docker, right?
If you do it through Docker and Ubuntu images, then you got capability pretty quickly, compatibility.
So you're saying that'll do it?
Ubuntu sounds great. I will take Ubuntu anytime. ROS 2 requires runs on Ubuntu. So yeah, of all distributions, as far as I'm concerned, Ubuntu is like, I'll take it anytime.
Like the Jetson Nano also runs Ubuntu. I mean, they package it differently and they have a different name for their OS, but it's actually Ubuntu underneath.
Yeah, it's good. It's so good.
So I think this maker pad is a great stepping stone for people trying to get into ROS. Sounds good. Now,
Thank you.
we can promise many times it's just a turnkey. You know, you just put the software on and it just works. But in the past, I've seen many robot kits that didn't really work. I mean, you put it on and then 6 months later, you're still in the weeds. So when you release the package, you're saying it works. I mean, I'm not doubting you. I'm just trying to say that's a big step forward, and it's really cool. Now, if we can figure out what we as a club need to do is figure out some sort of competition where we can use these robots. I mean, I'm talking about the maker pet, not your bigger model, because this is a good entry point. What is it, about $150, I believe?
Yeah.
And we need to figure out how to probably. And it looked like when you flipped up the schematic had about 4 pins or 5 pins free, and one of them it looked like it was an I2C bus. Is that correct? Do you have the otherwise is the I2C bus free?
Yes. There is I2C bus available. Yes.
Okay, so there you go.
Yep. Expandability.
Yeah. Okay. Great.
Yeah, I think Ray's probably the newest owner of a make that. So
Can that one Raspberry 5? Can that Lidar run the Raspberry 5 AI?
I'm sure they do. I mean, you got to program it, but you know, it doesn't come with a. It doesn't come with a. It doesn't come with a Lidar.
Well, I thought Raspberry 5 there's AI with that on it to have it.
Yeah, that's 13 or 26.
Your chief's heard about that.
This one has this board has
But like adding something like that, you know, it's just a serial port with a single pipe.
Yeah.
That's coming across this, you know, there's a steer. That would be.
I need to send you the updates I made, Ilia. I made some updates to mine, and I'll send you a list of what I made.
Oh, I'm sorry, I missed it. Can you say it again, please?
No, yeah. So I made a few updates to mine when I got it. I'll send you a list of what I did. Just little things like as I can see on the camera. No,
Oh yeah, I can see.
but I added magnets so that the LiDAR will just snap onto the post with magnets.
Oh, I see.
Let me get real close with the camera. Where are we at? Come on, camera. Right. Okay.
Yes, I can see it.
So I've updated the model as well, so it's 3D printed with the posts, because I know that shipping with the posts is probably going to break them. But yeah, I added magnets to the post for the LiDAR as well as the enclosure. It all snaps together nicely.
Oh, great. Awesome.
Yeah. That's one of the things. What else to add?
Awesome.
Yeah, adding the magnets to the LiDAR was great, because like having to take it off to reprogram it to like put it back on. So yeah,
that's awesome.
The best thing was adding a 4-pin connector to the LiDAR, because having the single, like you have to remember which colors went where, and it's like you have to look it up.
Right.
Having the 4.
Yes. Oh, that's a very good point. Yes.
It's not too hard.
I don't know if Curtis talked about this earlier. This is the camera you're using.
That's all right.
Oh, okay. Yeah, there it is. That's a Max Cam. So it's like a camera subsystem. You can do kind of like OpenCV functions on it. You can, take a series of photos of some object, make a model, load it. It uses, I think, YOLO 11. But, for like blob detection, like to find a can or something, all I have it do is output a single byte that represents the X centroid of of the location of the can, and I use that to steer. So, but the interface is very simple. It's just a serial interface at 115, 200, and a single byte. So there's no parsing. Just pretty much use it directly. So that might be something that would be neat to add. And as far as minimal overhead, I mean, it's just actually you only need a receive port. You don't need a transmit port. There's nothing transmitted back to the camera. So
sounds great.
Something like that. We can add.
Okay, I'll look it up now. Thanks for that. Yeah.
Anyway, so that's one of our contests. We look for 6 cans and try to bring them back into a goal, like a little mini soccer goal.
Yeah. I do like the idea of playing soccer.
Yeah.
Yes, it sounds like a good idea. I'll look it up now. So MAIX camera.
Oh, MAIX.
MAIX.
Yeah, and this is an earlier one. They're up to a Max Cam 2, and that one just has I think it's got a bigger screen,
Mobile missiles,
better camera. You can actually plug in different like there's a TOF camera that you can plug into it and do overlays of distance and the visible image, things like that. So
that sounds great. That sounds great.
I think you just looked that up. It was the older one is like $40. So not very much at all.
I was looking for something like this. Yes, because I need object recognition for apps.
Yeah.
Okay.
And
sounds good.
So you can take photos with the model. Oh, the Max Cam.
Oh, yeah.
Yep.
So,
Yep.
Okay. Well, if it's okay, I have to.
Of course.
I have to get back to my family. If you don't mind.
Enjoy your weekend.
Really liked it.
Thank you for having me. It's very great. It's very good to meet you all. So I wish you a good weekend. Thanks for having me.
Thank you very much, Ilia.
You too. Bye, Mark. Bye, everyone.
It's weird. I'm a little
Yeah. But
just started there.
I don't know what it is.
I think it's focusing on
the side is
the left side.
Yeah.
The whole right side is.
Yeah.
I don't know, I think we're gonna just look that way.
What's that? I'm just
The world-
focus.
the world-
Jim, just a blurry kind of guy.
Just a blob.
Yeah, not Bigfoot. He's continuously blurry.
That's right. No clear, distinctive images.
Yeah. All right. Well, we're done with the.
That was a very good presentation.
It was really good. Really entertaining.
We're still recording.
We are still recording. We're still live on air.
There's some of us out here still.
Just enjoying our pizza from 12G's Canada. No pizza for you.
You probably ought to take the recording off.
Smells really
Yeah,
good.
we can probably stop recording.
Okay, guys, I will stop the recording and I'll stay live though.
Yeah. You're welcome to hang out. I'm sure we'll have a hangout chat.
See what everybody thought.
Yep.